So, my dear students, today our class based on the Benz rule. Our class based on the Benz rule. In our previous 3 or 4 classes, we have already discussed some rules of basic hybridization. So, this is the Benz rule. So, I am first writing the two main clause of the Benz rule. First one, the central atom, the central atom the central atom projects the central atom projects the the hybrid orbitals of greater p character greater p character so greater p character, that means that is less s character, towards the more electronegative atom, the more. So I'll discuss all these two rules, but before discussing, I am just writing the two clause, and I am requesting my dear students to please note down the rules in your copies. The second rule says the central atom projects the central atom projects the hybrid orbitals of greater p character, of greater p character, that is less s character. The similar is of less s character towards what? Towards the ionic bond, towards the more ionic bonds, towards the more ionic bond and of greater s character, and of. So first of all, greater p character towards more ionic bond, and of greater s character, towards more covalent bond, So this is the basic two rules of Ben's rule, basic two clause of Ben's rule basically. So we will discuss these two laws with the help of a beautiful example, and the example is very often comes in your entrance exam, so don't miss this example basically. So I am going to remove these writings. I am requesting my dear students to please write down the notes in your copies, in your notebook, by pausing the videos, otherwise you will all forget it. So now we're going to discuss this law with the help of an example. So what is the structure of PCl3F2? Look, my dear students, there are two types of ligands, basically two types of substituents around the central metal. So central metal, or element. What is the central element here? Phosphorus. Phosphorus is basically a non-metal, so this is a central element. And substituent, chlorine and fluorine. And the electronegativity, chi. So chi fluorine is greater than chi chlorine. That means fluorine is more electronegative. Fluorine is more electronegative. Fluorine is more electronegative than chlorine. Okay, my dear students. So now derive the hybridization, state of hybridization of phosphorus. So what will be the state of hybridization of phosphorus? In our basic rule of hybridization, I have already discussed how to derive hybridization, and I will provide the link of that class in the description box. If you wish, you can go through our previous class by clicking this link in the description box. So the rule is this: H equals to half of Ma plus number of valence electron minus anion minus cation. So H, now H becomes number of monovalent atoms. What is the number of monovalent atoms around phosphorus? Here both the chlorine and fluorine are monovalent atoms. So number of monovalent atoms is 3 plus 2, that is 5. So a number of valence electron of phosphorus. So phosphorus is in the group of nitrogen. So the phosphorus, the atomic number of phosphorus is 15. So it gives 1s2, 2s2, 2p6, 3s2, 3p3. This is the valency cell. So number of valence electron is 5. Okay. So it gives 5. Okay, my dear students. So this gives 5. H is 5. So the hybridization is nothing but sp3d. So the hybridization, state of hybridization of PCl3F2 is sp3d. And in our previous class, we have discussed the detailed shape of sp3d. And I'll provide the link of that class also in the description box. If you don't know, if you don't watch this class, then you should go through this class. Provide the details provided in the description box. Then only you can understand what are the two basic shape of sp3d hybrid orbital. So here the state of hybridization is sp3d. So it has the two possible structure. One is trigonal bipyramidal and another is square planar. Now my question is that what will be the possible structure of PCl3F2? What will be the possible structure of PCl3F2? Looks here, the types of atoms, different types of atoms are two: 3 chlorine and 3 2 fluorine. And in if the structure will be square planar, then there are only the place of the two different types of ligands. But here, so the requirement of square planar is that the equatorial, this is the equatorial point, this is the equatorial point, this is the equatorial point, and this is the axial point. So equatorial point will be 4 and axial point will be 1. And here this is the equatorial point, This is the equatorial point. This is also the axial point. So number of equatorial point is 3 and number of axial point is 2. Okay, and here the equatorial point, this set belong S, Px, Py, and D x square y square, and the axial plane Pz. And here the equatorial point is nothing but S, Px, and Py, and this gives 2. This is Pz and D z square, and here E for equatorial, and A for axial. Okay, my dear students. So what will be the shape of PCl3F2? Now look here. The Benz rule says the central atom projects the hybrid orbital of greater p character. So here the percentage of p character, uh, here the percentage of p character, the percentage of p character, how much? Here the percentage of p character, and here the percentage of p character. Okay, so in here the percentage of p character is what is 66%, and percentage of s character is 33%. Okay, and here percentage of s character is 0 because here no s is present, and percentage of p character is 50%. So in basic structure, here the phosphorus, three equatorial plane are occupied by chlorine atoms, and the two axial planes are occupied by fluorine atom. Why? Because we can see from the Benz rule that Benz rule says the hybrid orbital of greater p character was projected towards the more electronegative substance. So as chlorine or less s character. Okay. So although the percentage of p character, although look wisely, although the percentage of p character is 66% or 50%, the percentage of p character is greater. Although the percentage of p character is greater at equatorial position, but the percentage of s character is almost is zero, or not only almost but totally zero in axial position. So the more electronegative fluorine atoms are occupied along the axial position with zero s character. Okay, because fluorine is more electronegative, so as per Benz rule, the more electronegative fluorine atoms are placed on the axial position, and the square planar this structure is not at all possible because here the two different kinds of substituents are present, and chlorine has number of chlorine are 3, number of fluorine is 2, and it is no, it doesn't match with this formula 4-1. It matches 3-2 because number of chlorine atom is 3, number of fluorine atom is 2. It does not match. So square planar structure is not possible. If not possible, the main structure will be trigonal bipyramidal. Okay, my dear friends, so this is the very good example of a Benz rule, and in our next class we'll see some more interesting examples of Benz rule. Okay, my dear friends, so be with us and watch our channel Easy Chemistry. I hope you can learn something out of this class, and these classes are very helpful for you to crack some difficult questions in any entrance exam. It can be of IITs, it can be of JEEs. Okay, my dear friends, till then, goodbye.